So yeah, next slide. Let's go ahead and get started. Yeah, let me go ahead and share my screen. Okay, can people see my screen all right?
Yes.
Okay. So feel free, as in the Amish presentation, to raise your hand, speak up in the chat if you don't understand anything, if I'm going too fast, because it's very important in live coding demos is to, if you get lost, let us get everyone on the same page, because we hate to see you not understand something. So yeah. So I'm assuming everyone has Orange installed, and you can go ahead and open up the program, and it gives you a nice blank canvas with which to work on. And on the left-hand side are the different sets of widgets that you can use to perform different tasks or with your data. But we're going to be going through a number of different of these today. But the first one is the data that we sent out was a CSV. So what you can do in the data tab, you can click on the CSV import and drag it over to your canvas, and it creates a little CSV widget. So I'm going to, okay, right click. There we go, rename. So I'm going to be loading up diabetes data. So I'm renaming this so I know exactly, for myself, what the data is. I double click on it, brings up a nice little window. I could see import any file. So you should have received some data called diabetes.csv. Go ahead and open that. My multiple screens are probably might be messing this up. Let's see here. Where did it go? There. No, that's not it. Okay, let's try this again. Okay, I've seen this happen with multiple screens before. In orange, the menu gets put someplace else, which I'm looking for. Let's see that. Let me go ahead and close this window and reopen it. Yeah, okay, some error, that's all right. Let's see. Open up Orange again. Sorry about this, folks. This is the fun about having live demos. You get to have little fun scenarios like this, and something doesn't always work correctly, and that's okay. Reload the last one. Okay. And off to the side, I also load up my reference file. Which, there we go. Now it's on the screen. Okay, let's try this again. So we're going to import the file, diabetes.csv. There we go, it's working nicely. So you can see a preview of your data. There are 9 different columns. And if one thing that's really nice that Orange does is you can specify the type of data that's in each column. And so for this one, it's going to do an auto, but we know it's numeric. And I would encourage us, since we don't have too many columns here, to label each of these as numeric. It just explicitly makes sure the algorithm knows what we're doing is with numbers. And this is important, especially at the very end. Make this a little bit bigger. There we go. The class. This is that classification category that Amr is talking about. We're either going to be looking at testing positive or negative. So this is a binary classification. So we want to make sure we say this is categorical. Incredibly important to label that. And go ahead and finish the other ones with numeric. Okay. So now we have all of those labeled. Let's go ahead and click OK.
Hey, Chreston, just a little note here.
Yes.
So for those data, you might have categorical fields even in the features. So Chreston was actually labeling the features and the label. So the label was categorical, but you can actually have categorical features within the features, categorical data within the features. Let's say, for example, as I said, male and female. Male and female can be one of the features, and it should be categorical because now Orange is going to do it for you to convert this into a numeric format.
Yes, thank you, Amr, because some of your features can be categorical themselves. So very good point. And this gives you a nice, some information about how many rows you have, how many features. The meta in orange deals with if it's a text field, which we're not dealing with today. Okay. Now, what we want to do is be able to select columns so we can tell the algorithm which features we want to work with. And to do that, we can actually just left click and drag. We got a little arc or edge, and it opens up a nice little searching for a widget. And what we're looking for is select columns. And if we open that up, this right now, it has everything in the correct place. We have the features that we want to use over here, and have a target class. So this is why labeling the data as we did when we imported it helps Orange know how to organize the different features. So the target is the class, which is great, and it's using these features when we're going to be running the algorithms. Okay, now one thing before we get into selecting different algorithms to work with, what's really nice you can do in Orange is you can do something called distributions. And this gives you an insight into what's going on with your data, the characteristics of it. So I can look at specifically the class and see how many, let's see another one, yeah. See how many are tested negative, how many tested positive. I'm not gonna do that right now. There we go. There we go. Now I can see you hold over and say there's 65% negative in our data and almost 35 for positive. And it's nice because you can go through and click on these different features and get histograms of distributions. And there's a couple other options, things you can play with. But this is nice to kind of explore your data before you start working with it, because it's good to see the type of features you might find within types of characteristics of your features you might find. And this is very important in a step later that I'll show how working with this can show you something interesting about your data that you will want to fix. Another way to view your data also is called feature statistics. And it's like the distributions, but it has the histograms of your data, and it has other information like the mean, the median, dispersion. Oops. Name again. Okay. Dispersion, which is like the standard deviation, min, max, and this is very nice. It tells you how many data points are missing. Missing with respect to if there is a column that in some row has no data in it, like it might be not a number, NaN, or a null, or just empty. Orange would say, okay, that's a missing value because there's nothing there. And we'll see how this plays into it in a little bit. So that's two nice ways that we can view our data before we even start looking at it. So we can kind of get an idea of what is there. So next, we're going to set up the backbone of testing. We're going to test 4 different algorithms. First, we need to set up what's called a test and score. And so this takes the data that you have passed in the selected columns, and you can connect different models to this test and score, and it'll automatically run that model or algorithm over that data. So what we first are going to test is what is called constant. And if you're not sure what constant does, you can click on it. And on the bottom left, where there's a little window, it says, tells you exactly what it does. It predicts the most frequent class or mean value for the training set. So this is our baseline that we'll be able to test against. And okay, so Amr talked about random forest. So let's go ahead and do a random forest. Another one is called support vector machine, which can look for different types of boundaries within your data, linear or nonlinear. And lastly, we're going to test a logistic regression, which is one of the classic algorithms in machine learning. And what's really nice is we have actually built a pipeline that tests 4 different algorithms in just a few clicks on your data. So if you open up test and score, you can see the evaluation results here, and CA is classification accuracy. So I sort by that by clicking on the column header, and you can see that logistic regression actually is slightly better than the random forest in classification accuracy. And you can check out this F1 score, precision recall, area under the curve, other different metrics in machine learning for algorithms. And so this is nice because this gives you an idea of what models might perform well, may not perform well, but this gives you a good start. But one thing I want to show you that's interesting in that if you poked around in distributions, one thing I want to point out, oh, I got my cats who are invading my space. Hold on one second. Okay. So one thing that's interesting, if you click on mass, there's a mass of 0. I'm not sure about you. I'm not no physics person, but I know you can't have a mass of 0. So there's something wrong in our data. And so what we can do to play with that, actually, let me make this a little bit bigger. There we go. What we can do, oh yeah, here's another nice thing. Select, I can move everything. It's pretty nice. We can take what we have selected, and we can use something called a feature constructor. And what you can do, I know we said this is no coding. This is the one place you have to type one line of logic, and it's based off of Python. But I'll walk you through it. Very simple. Let me get rid of that. There we go. Okay, so what we're going to do is we want a new numeric constructor, because we're dealing with mass, we want to be able to fix mass so we don't have this mass of being 0. So it's numeric. So we're going to name this new feature non-zero mass. And here's the one line of code that you have to use. It just says mass. So using the value of mass, if the mass is greater than 0, else or otherwise, it's not a number. And that is all you need to do. I'll keep that up a moment so people make sure they get that written down. Typed up, I mean. Okay. So next, we're going to take a look at the feature statistics and see what the data looks like now. So now we have mass here. We still have that 0. But we go down to our new variable, new feature, non-zero, and that disappears. And we get a new looking distribution because we're not being affected by that 0 mass. However, all the way on the right in the missing column, you see that there actually were 11 cases of the mass being 0. So we're missing, it calculates 1% of the data, roughly. So what we need to do is fill these 11 values in with something that makes sense. And so since we're dealing with mass, a continuous value, and this is also dependent on the data and domain you're working in. Like, your data, what makes sense to replace it. And so I'm going to show you some options that you can use. Guys, there we go. So what we're going to do is we're going to take those missing values and replace them with the average value found in the data. So we're going to do something called we're going to impute those values to a given value that we want to have. And by default, it actually does the average or most frequent of any missing value. This feature, the non-zero mass, is the only one that has missing data. And we know that from looking at the feature statistics. However, if you wanted to narrow in and do a specific one, so we just want non-zero mass and we can specify average most frequent. So we can do that for every single one. We can specify anything specific of the options given. So, okay. Now, let's look at the feature statistics again. If you look at non-zero down here, we have 0% missing values. And you can check to see that something has been done by comparing with the mass feature. You can see that the mean is almost 32, 31.99, but the mean down here is 32.45. So it has been updated. Some new calculations have been done. So you can move on. Now this is where that selecting columns feature widget really comes in handy, because previously it was cut and dry, cookie cutter. It knew It knew exactly. However, we have a variable now, a feature. Generally speaking, it's over here. Because I worked with this before, I put it in the ignored pile. But when you start out, you have this non-zero mass, which is the feature you just created, and the mass, which is the one you know has some invalid values. So you can select it and move it over to the ignored column. And when we do the next iteration of machine learning algorithms we want to test with this new feature, non-zero mass, the mass column feature will be ignored. Okay, so what we can do, this is really slick in orange. I'm going to go ahead and select this section. I'm going to copy. I'm going to paste. Oops. Make this a little bit wider. And now we can grab select columns, write the test and score, and it runs all 4 algorithms on us on this new updated data set. So we can look at the results, classification accuracy, and actually logistic regression does the best again. Random forest goes down a little bit from 76, 77 to 73. And so from these 2 different tests, we realized, okay, logistic regression works. Working with imputing the data had a little bit of effect, but sometimes it can be more than others. And this time, since it was kind of small, I'm just going to use the original data. And you'll see what that means here in a moment. Okay. So now that we have decided that logistic regression using the original data is what we're going to choose to do, is we're going to take the logistic regression widget, and we're going to go down to what is called predictions. And this is where we need that other CSV that was provided, which is I'm going to rename this so I know, diabetes predict. And I'm going to open up that other CSV file. Oops, not recent. And it's the diabetes-predict CSV that was also provided for this workshop. And you can see all it has is 8 different features. As you can see, the class is not there because we're trying to predict the class. And I'm going to go ahead and let Orange do an auto detect of these columns because there's nothing special going on. They're all numbers. I don't need to specify anything explicit like I did before specifying a categorical column. Okay, and there's only 5 there. Okay, so now I can just connect this data source to the predictions. And also, just forgot, I need to select from the selected columns, which is the original data, down to logistic regression. And now we can look at predictions. Oops. It's a little bit bigger. There we go. And so we can see for each row, which one's tested positive, which one's negative. And this is actually just a tutorial example because these first 5 examples are actually from the first 5 lines of our original data. So the accuracy on this one is actually pretty good. If you click on testing negative, it gives you a nice little score. and a visual line that represents how large that accuracy was. So 95%, 96%, these two are negative, and same for the other three testing positive. So those are high. It's to be expected since we use this, copy this from the original data. I'll show you how to do this. What we just did was basically a training data and a test split, where the original diabetes CSV was our training data, and the diabetes predict was our test data. But you know, the predict data came from the original data. So what if we want to just use the original data and split it up that way without having to have two separate files and everything? Orange makes that easy, thankfully. So what we want to do is I'm going to go ahead and copy the loading and the selecting columns. It's bigger. And we're going to use something called a data sampler. And what this does is you can tell it how much data you want to split. I mean, the percentages of split. By default, it does 70%. Generally speaking, in machine learning, a train test split is either 80-20 or 90-10. Sometimes they go lower depending on characteristics of the data. I'm going to keep the default at 70% just for this demo. So I'm not going to change anything in the data sampler. Since we're testing, we know we want to use the logistic regression. We go ahead and choose that algorithm. And we know we want to make predictions. So we connect to the predictions. Now, there's one piece missing here. What you can see on this line, as you may have noticed from the different connecting lines, it tells you what type of information is going over that line. So for these, the data is going here, here. There's a learner, which is the algorithm. To predictions, there's a model going to predictions. So this is very useful to know what's going on, what are the interactions between the nodes. So therefore, with the data sampler, it says sample data, a data sample to data. So it's like, okay, there's part of it being sampled. Where's the rest? Where's that other 30%? Because we chose 70% for train. So if we connect the data sampler to the predictions, we can double click on this and see data sample. No, that's not what we're using. That's going to the logistic regression widget. So I click on that to remove it. And I say, I want the remaining data to come in to predictions. Okay, so now we have created a pipeline that loads the data, does a train test split, tests the trains on the logistic regression, and provides predictions on the remaining data, the 30%. And this provides, on the bottom, you can see, it's probably hard to see on my screen, but on your screen, it should say 230. That's how many were in the the test data. And that's what we see here. We have logistic regression model. We have the actual class it is, because since we're dealing with test, it's labeled data, we know what the actual answer is, so we can compare with that. And it gives us the values that were used in training. Now, what if you want to save this? Because this is information that's very important when you're running your experiment. You have all these predictions, and you want to be able to save them. So what you can do, keep this, close my feature constructor. we want to be able to save this data. Yeah, so save data. Predictions to data. The one thing I learned when I was looking at this the other day, in order to save, go ahead and you have to select everything you want to save. And then when that's selected in the predictions widget, you can go ahead and double click the save data. And since we want a pure CSV, which means just the header and the values in each column, we don't need the type of annotation, which is what some metadata that orange adds, like it's a numeric or categorical or anything like that. So if we go ahead and we don't want the annotations, we save it. Now it wants to make it into a tab separated file at first. So if that's what you need, that's fine. But you can also do comma separated. And the one thing that's a little bit annoying is you have to go up here and change the file extension, CSV. And let's go ahead and put this as, let's see, what did I name before? Diabetes, logistic predictions. There we go, diabetes logistic predictions. Go ahead and save that. Close that guy. And if we look at that file, here's our CSV. It might be a little hard to see on your screen from mine, but we have the first 8 columns are the values, and then we have the class that's labeled as, then what the logistic regression did, and we have the probabilities provided. So the first one tested was predicted positive, even though the class label was negative. That's funny. And it gives you the probabilities of being negative and positive. So this is a way you can look at the results and save it out for ingestion into other software you might need or whatnot. But there is one last step, the last thing to this whole pipeline. You've trained this model. It's what you want. How do you save it and reuse it later? Well, the logistic regression model that we're using, I'm just picking one of them, that we used in the first predictions task. Simply enough, you can just say save model. And go ahead and save, and we name the model. Let's see. I think I named it. Yeah, diabetes logistic model. And it uses the file extension is something called, in Python, called pickle. It's a type of way of saving out some data in an encapsulated format, and then you can reload it. You reload the pickle. So you're pickling something up, like, make a dill pickle. It's kind of a play on words that they use. So yeah, let's go ahead and save that out. Okay, yeah, I know it already exists because I've taught this class before. That's fine. Okay, so now, great. Now we can load that data, that model, so we can actually perform predictions on new data. So what you can do in the canvas, you can right-click. You can get the same little search for widget menu up. You can do load model. So let's go ahead and load up. It's smart, thankfully. It knows which file extension it can load. So it's that pickle file extension. And we go ahead and open that. And we need the data itself. So I'm actually using the same 5 samples of the prediction data I did earlier. So I'm just going to copy and paste this loading CSV. And we know that with this data, we want to do predictions connected to the loaded model. And we can see what the predictions were here, in this column. And you can do the same thing as before. You can save your data. And so now what you have is a full pipeline where you can start with your selected data. You can specify what columns, you can explore your data with the distributions or features. You can do a testing and scoring of different algorithms. You can perform some imputing or reassigning some empty values. So you can kind of clean your data a little bit. You can perform predictions. And you can have a nice, and down here is a nice clean way example of how to start from the beginning to the end with training and test data, train test split. Showing you how to save the output of your predictions, save your model, load your model up, and try predictions on new data. And so what we end up here is a nice little workflow. And I hope, I know for me, I use these as templates in the future when I'm working on different problems. And yeah, so that's what I have for our hands-on demo. And I see we have a little time left, which is great, because I'd love to hear any questions or comments you might have. Are there any in the chat, Amr?
No, Chreston. So thank you for the presentation. If you guys have any questions, please unmute yourself if you'd like to. And I also posted a link to a YouTube list. It has a bunch of features for videos for if you would like to know more or learn more about Orange. How would you like to use it? As Chreston illustrated, it's straight. I mean, it's nice that you don't have to write code. One of the actual motivations of this course is that many of the tutorials or the sessions that teaches machine learning through code actually digs deep into Python, which becomes like kind of hard for people to grasp. So the nice thing about Orange is you just drag and drop the widgets and connect things together, and voila, it works. So I hope that you guys have learned something new today. I hope that we were able to help you. Of course, we still have a few minutes. Again, if you have any questions, we'll be happy to help. And also, we will share the presentation with you, and you also have the recording. So if you would like to contact us for any questions, you have our emails. We'll be happy to help overseas. So yeah, I mean, any questions, comments?
Hello, everybody. I would like to thank you all for this beautiful opportunity. Thank you, Chreston and Amr. It's been a pleasure to have you and explain us all this world of machine learning. And we created a form, a survey. So I will ask everybody to just fill it out. It's in the chat. That will help us a lot to really improve jobs. About the information, we are going to share all the information, the video recording and document and the material on Material Pioneer's website. So check it out. And yeah, I would also like to thank our collaborators, which are not here today. Some of them are not, which are Yasmil Turkimaz, Connie Claire, and Paula. Thank you so much. And yeah, final words.
Well, thanks
Well,
everyone.
thank you for-
It was a pleasure to be with you today. And as we said, we would love to collaborate. If you would like any help, we'd be happy to chime in.
Yeah, thanks for
Yeah,
having us.
Thank you for a lovely, lovely small brief course. You've given me a great ideas how to go about tackling my problem. So that's thank you for that. And perhaps if we could, exchange information, and down the line we figure out something that we run into a wall, so to speak, then maybe we can reach out and discuss accordingly. But for now, thank you so much, and perhaps until later.
Absolutely. Thank you, Cedric.
Thanks everybody again, and we'll see you at the next workshop session. You can find all the information on our social media. So feel free to reach out to us if you have questions. Thanks and have a beautiful day.
For you too. Thank you. Bye-bye.
Bye-bye.
Bye.
Thanks. Bye-bye.